Bismillahirrahmanirrahim. Assalamu alaikum dear students, how are you all, and welcome back again in online classes. And we will start from BRONSTED slurry concept of acid and bases. And you know that we are studying about second chapter and about concepts of acids and bases. In 1923, the first heading is introduction, and it's long question 2 of exercise. And starting from here, in 1923, the Danish chemist BRONSTED and English chemist Lowry independently presented their theories of acids and bases on the basis of proton transfer. According to this concept, first of all, definition and statement of this law, Lowry-Brans's concept. An acid is substance, molecule or ion that can donate proton to another substance. A base is a substance that can accept a proton from another substance. For example, HCl acts as an acid while NH3 acts as a base. In this second heading is the statement, and the third is example, and we will further explain this example by this equation. He said that acid is the substance which can donate proton or hydrogen positive ion, and base is a substance which can accept hydrogen ions and protons from the acid and from the other substances. For example, you can see here that HCl and ammonia, when they will react, hydrochloric acid will donate its hydrogen ion proton in the form of proton H positive to the ammonia, and it will convert into NH4 positive by accepting proton, and in the form of hydrogen ion positive ion it will convert into ammonium ion. And the second one is chloride ion. After donating proton, chlorine will get negative charge and will convert into chloride ion, and hydrogen will transfer to the ammonia and it will convert into ammonium ion. Similarly, when HCl is dissolved in water, HCl acts as an acid and water, and you can see here that HCl, when donate hydrogen ion to the water, it will convert into hydronium ion, which is H3O positive, by accepting hydrogen from chlorine. In this reaction, hydrochloric acid acts as acid and water as a base, and after donating proton to water, because base accept proton from acid, it will convert into conjugate acid. Simple base will convert into conjugate acid, and because acid donate proton to base, and it will be called conjugate acid, and after donating acid will be called conjugate of base because it requires negative charge. Let's discuss the conjugate term in detail. Conjugate mean when HCl donate proton to water, it will convert into hydronium ion, and chlorine require negative charge. It's mean now because chlorine have negative charge, and it can also, and it will act as a base, and when it can accept again hydrogen to reform acid, so it is called conjugate base. After losing hydrogen ion, hydrochloric acid, in the hydrochloric acid, after losing hydrogen ion, chlorine get negative charge, and now it will act as a base because it has negative charge, and it could again can rejoin with hydrogen to form a acid, and somewhat now chloride ion has the property to accept and ability to accept a proton, and that's why it will act as a base. That's why we said conjugate base. Conjugate mean coupled and joined. So when hydrogen water accept proton from the HCl, it will convert into conjugate acid because it has extra hydrogen ion, and it can donate now, and it can act as proton donor because it has extra proton now. And similarly, after donating hydrogen ion to water, chlorine acquire negative charge. It means now it's acting as a base because it can rejoin with hydrogen ion, and it can accept hydrogen ion from again from the water, and it can act as a conjugate base. Another, you can see another point of view. For example, left side of the reaction, HCl is a acid and base. What is a base? But after donating proton and accepting proton, it will convert into hydronium ion and chloride ion. Hydronium ion, now you can see that here in this product, hydronium ion has extra electron. It means it can again donate electron. That's why it is called conjugate acid. And the second one is chloride ion. And in this product, chloride have an active charge, and it can accept hydrogen from the water molecule. That's why it acts as a conjugate base. So it is clear that what is the conjugate acid and conjugate base. Actually, conjugate acid, after rejoining, when acid and base react with each other, after rejoining, after conjugation, hydronium base will act as a acid, and the acid will act as a base, and their properties will change, and you can say that there will be reverse in properties. Now after accepting proton, water will convert into acid. Almost temporarily it can act as a acid, and we can say that after donating proton, chloride ion will act as a base, can act as a base because it has now ability to accept proton. So this is the term which is called conjugate acid and conjugate base. Next, it is a reversible reaction. In the forward reaction, HCl is an acid, it denotes protons, whereas water is a base, it accepts proton. In the reverse reaction, chloride ion is a base, it is accept a proton from the acid into ion. Chloride ion is called a conjugate base of acid HCl, and hydronium ion is called a conjugate acid of base water. It means every acid produces a conjugate base and every base produces a conjugate acid, such that there is a conjugate acid base pair. Conjugate means joined together as a pair. And definition of conjugate acid: a conjugate acid is a species formed by accepting a proton by a base, or conjugate base is a species formed by donating a proton by an acid. When acid donate a proton, it will form conjugate base, and when a base accept proton, it will form conjugate acid. Thus, conjugate acid base pairs differ from one another by a single proton. Similarly, acetic acid, when react with water, conjugate base it is formed, and conjugate acid is also formed. And because in acetic acid, hydrogen is partially ionized and gives its proton to water. In this reaction, in the forward reaction, you can see acetic acid is a acid acting as acid by donating proton, and water is a base by accepting proton. But in the reversible reaction, you can see that here it is now conjugate base acting as acid is acting as a base, because now after losing proton, it can accept and it can rejoin with hydrogen to form a acid. That's why it is now acting as a conjugate base, and hydronium act as a conjugate acid, because after accepting proton, now it can donate, it has extra proton and it can donate proton to any other substance. So in reversible reaction, conjugate acetate ion is conjugate base because it has the ability to accept proton because it requires negative charge, and similarly conjugate acid, it's mean water, has extra proton and it can donate, and we know that any substance which can donate proton act as acid. So because they are formed by rejoining of protons from one substance to another substance, and that's why it is called conjugate base and conjugate acids. According to BRONSTED Lowry concept, an acid and a base always work together to transfer a proton. That means a substance can act as an acid only when another substance simultaneously behaves as a base, proton or acceptor. Hence, a substance can act as an acid as well as a base depending upon the nature of the other substance. For example, water acts as a base when it reacts with HCl as stated above, and an acid when it reacts with ammonia, such as you can see here in the above reaction. Water when react with HCl, it is acting as a base, and when it react with ammonia, it will act as a acid, because in this reaction water will donate hydrogen ion to ammonia and it will convert into hydroxide ion, and such a substance that can behave as an acid as well as a base is called amphoteric. It has been observed that there are certain substances which behave as acids, though they do not have the ability to donate a proton. And the last paragraph heading is the limitations, and we know that sulfur trioxide and calcium oxide. Sulfur trioxide is a acid and carbon dioxide. Calcium oxide is a base. We know that sulfur trioxide is a non-metal and they have stick in nature, and while calcium oxide is a metallic compound, that's why it will act as a base, but they don't donate and accept proton. And this is the limitation of this concept, because it deals only with that atoms and substances and molecules which can donate or accept proton only. Limitations of Bronsted Lowry concept of acid and bases. And after that, here it is some examples of acids and base and their conjugate acids and bases. We will discuss in our next lecture, and till then, Allah Hafiz, have a good day.